This is a tutorial to learn how to design ship in Blender. This tutorial is not for complete beginners in Blender. If you are a complete beginner, I suggest that you watch the Blender Guru tutorial on how to make a donut first. It will show you all the basics and you will be able to come back to this tutorial to design a boat. So we will start. In Blender, when you arrive, you'll see your default cube, and the first thing we'll want to do is to create a ship design environment. In ship design, there are some basic rules that everyone applies. So one of those rules is the domain of shipbuilding, the axis in which the boat is oriented. The x-axis is forward, the y-axis is port side, and the z-axis is the top. So here we have our cube. We'll go into edit mode. The back of the boat is against the y and z plane, and the forward of the boat is here, port side is here. That's what it looks like. Then you'll want a more subdivided hull, so you'll go into here and type in subdivision surface. That's it. You'll need something smoother. There you go, that's smoother. If you've got powerful computer, you can again go to 4. There you go. Then it's not looking smooth. Shade smooth by angle. And it's not looking like a boat. Boats have some flat surfaces. So the transom and the deck. You can change that. Some boats do not have a flat deck nor a flat transom. We'll see that later. Still, that's basic. Then the length of your boat. Most boats that you're going to design will generally be in the 6 to 24 meters range. So a good start is to go between 6 or 8 meters, something like that. So I'll just type in 6 meters. 6 meters. Oh, actually, I'll get that to 6 meters. Yeah. So that line is at 6, and you've got this basic shape. No, that's not a boat already right now. So we'll want to still work a bit on it. First, a loop cut down the middle, and you can get rid of the entire starboard side. You'll get mirror function. You can have an asymmetrical boat, but that's not the case for most boats. They're generally symmetrical along the y-axis, and sometimes symmetrical along the x-axis, but those are specific boats. So you've got that shape. We'll want more geometry, not too much, just a bit more. A loop cut down that side. 1 is not enough. 2 could be enough for a simple boat. 3 is what feels comfortable for most boats. A simple boat will only require 2 divisions. A more complex boat, such as a large shipping boat, will require something like 8 to up to 10 division, but only create this division when necessary. Always start with a simple shape, or you'll get lost into it. So we have a bunch of control points, and we have a build here. We can work with that build. First, let's lift a little bit. So here we have that build. We can intensify that build up to having a sharp build, like so, or a completely round build. Obviously, we can also move the vertices around here. So if we want, for example, let's go for a basic motorboat design. So close in here, move that a bit forward, move that too, get that a bit larger, perhaps just that one around here. Move around the vertices until you're happy with what you've got. That's what matters. So, an old style type of motorboat, let's say. A simple one, I'm not going to spend too much time on that. Anyway, move around the vertices, do whatever you want. I suggest, before you do that though, just since you're not too far into it, if you want to design a lot of boats, from that point you can just go into preferences somewhere around here. No, file, default, save as startup file. That will be a basic boat you'll always be able to come back to start a new project. That will save you all the time we just spent doing the first few steps. That creates that hull. So I'm not going to do it. I have my own startup file already. It's another boat, more common to the type of boat I design daily, but well, that's basic. Here, and let's keep it very simple, not waste too much time, but just a little bit of geometry. Here goes up the bilge, as you can see. It's where the design element arise. Here we've got something. It's not beautiful, it's not anything, but we'll work with that to be quick. You'll have to spend hours, quite literally, getting experience on how to create a boat that you feel is beautiful. That's a lot of work, a lot of time to spend. I'm already getting carried away, so here, let's stop here. And another element before we finish. For the next part, we'll explore how to define the geometry, specifically the hull. So here I've just duplicated the basic hull, and I'm just going to move inward by 1 centimeter everywhere the geometry. So 1 centimeter up at the bottom, 1 centimeter inward on the port side, 1 centimeter back from the front, and 1 centimeter into the front. It might be more if it's a bigger boat. I'm considering a basic plywood boat with 10mm plywood. That's what I work with most days. But if you're on composite boat, it can be a few millimeters. If you're on steel boat, it can be up to a few centimeters. And you'll use a lot of this function, Boolean function. Here, by using a difference from our basic hull to our slightly moved inward hull, we can get this. And in the new version of Blender, you've got that small geometry error that appears. The way to fix it is to go smooth by angle. And same for the minus hull in the Boolean difference. Smooth by angle. And this didn't work. Why? Always smooth by angle. Did I forget to do it on that one? Yeah, I didn't apply it. So I applied on that one, I applied on that one. Oh, I did too smooth by angle. Okay, that's why. Okay, so on every single subdivided element, remember in the 4.1 version of Blender, smooth by angle all the time. When you'll be designing your hull, keep in mind, if you want to make a real boat that will work, to do a Boolean function to estimate the volume of your boat. Download the 3D print add-on that has a volume section, then Boolean from your hull to your waterline, intersect volume. This hull is for 700 kilos in salty water, 672 kilos in fresh water, in lake water. So there you go. You might want more, you might want less. Modify the boat however you want, depending on your needs and desires. That's the basic idea. And remember also to look at the surface at the waterline. The larger it is, the more stable the form stability is, the more profiled it is, the better the displacement speed will be, the displacement efficiency. That's the gist of it. The rest in the next part. Thank you.